Okay, so hi everyone. So welcome Yuri to the DevOps Insight Hangout.
Yeah,
I,
thank you for having me.
um, so this is a Q&A session, right? So we have some questions that people ask beforehand, and I have a few questions. That's okay with you, right?
Yep.
Okay, so first of all, could you tell us a bit about yourself? Like, how do you come up with Jaeger? What were you using before Jaeger in Uber, and um, well, were you using something custom or something open source before? And
Mm.
okay.
Okay. So the story started with when I joined Uber. Uber was investing into a homegrown RPC framework, which was open source, but didn't really get popular in open source. But gRPC wasn't available, and so we needed something robust for the Uber scale. And that framework supported natively as a distributed tracing, very similar to how Zipkin was implemented in terms of tracing and context propagation. And so there was a kind of a prototype backend that someone built, which was receiving the tracing data from those RPC framework calls and converting it into Zipkin format. And so that's how we started. But then we essentially, when Jaeger started, we initially implemented the same component not as a prototype but as a production system in Go, which was receiving this custom span representation and saving it in the Cassandra database in the format that Zipkin UI would understand. And so that's how we started. So it's like half homegrown solution and half of the open source Zipkin project. And then eventually, as we started participating in open tracing project, Jaeger clients, which were built in open source, originally actually were supporting also Zipkin format. They were emitting Zipkin spans, but then because Zipkin format didn't really support like a KV login part of the open tracing, we switched it to Jaeger internal format, um, which is slightly richer, like very minor
Mhm.
richness there. And at that point, we kind of said, okay, well, it makes sense to build a different front end as well, which understands that data model natively. And so at that point, we dropped the Zipkin UI part, and Jaeger became completely standalone.
Okay, thanks. Um, there's a question we got a lot because we had somebody from Linkerd on the show a few weeks ago, and a few people ask, is a service like Linkerd enough for a small project, or do you think that even small project can still benefit from Jaeger, and in what way do you think?
Well, Linkerd is a service mesh. It doesn't give you an actual observability into what's happening within your architecture. So you still probably want to run Jaeger as the backend for getting the telemetry data. Plus, you may want to run Prometheus for metrics that Linkerd would emit. So if the question is whether it's sufficient to just have Linkerd as the only piece of infrastructure in addition to Jaeger, then the answer is no, because an application, um, even if your traffic goes through Linkerd or any service mesh, they are not able to actually generate proper distributed tracing data because they lack correlation between inbound and outbound requests
Mhm.
of a given service, right? And so the fine print in all service meshes when they talk about distributed tracing is that you still need to propagate a small piece of context within your application, usually at least like a standard header that contains the trace context in it. And the kind of ironic part about it is like if you think about how to implement that propagation in an application in multiple languages, potentially with multiple frameworks that your company may be using, you end up with the same complexity of the instrumentation as you would get by instrumenting with open tracing in the first place. And so it's sort of, yes, if you already have an architecture which propagates headers front to back automatically, then you can get away with just service mesh and get full distributed tracing support from that. But if you don't have that proper context propagation, then implementing it is the same complexity as implementing a regular distributed tracing.
Yeah, I agree. Um, Another question we had is, how much overhead do we add to our system by having a trace like Jaeger? Is it 100% non-blocking, or does it slow things a bit?
So Jaeger collects or introduces two data paths in the application. One is the propagation of the context itself, which contains like trace ID, span ID. Those things are passed as part of your business requests, and so they increase slightly the payload size. It's a tiny piece of information, but that's what goes on the wire with every business request. And then in parallel, the actual profiling data, like how much time a span took, what the name of the span is, what URL was hit, things like that, that information is collected in the background asynchronously and then reported also asynchronously. So as far as the overhead, so there is some CPU overhead because that asynchronous process in the background still needs to run and still need to collect data and send it out to Jaeger backend. There is a bit of an overhead on the hot path of essentially managing propagation of that context plus creating of a few temporary object like a span object that's created for an inbound request. um, and that overhead depends on how much work your service is really doing. If you are a very lightweight proxy like nginx, then the overhead might be actually significant if you actually trace every single request. Whereas for normal business services, even if you trace at 100%, the overhead is probably not going to be noticeable significantly. I mean, like less than 5%. I've got some people who doing like 100% tracing. They've seen 5% overhead on CPU, and there's some impact on throughput and latency as well.
Okay.
But with sampling, like typically the Jaeger is an upfront sampling tracing system, so you typically run with the like a probabilistic sampling at the beginning, and so you're not actually tracing every single request. And in that case, if you're not trace a request, then the overhead of tracing instrumentation is almost negligible.
All right. Um, Someone had a question about sampling. How do you detect what to keep on disk? Do you have holistic to detect errors and long latency? Is this something the user need to specify, or is it automatic?
So that's actually a pain point in Jaeger currently, and in fact, in many tracing systems that you find on the market. As I mentioned, Jaeger is a upfront sampling. What it means is that as soon as you start a new trace, and typically it's a request coming to your, let's say, API layer or through the gateway, you see that the incoming request has no trace information, so you start a new trace, and at that very same moment, you make a sampling decision. And since you have no information about how that request is actually going to behave later on, the sampling decision is by necessity very limited. You can flip a coin. Probabilistically, that's what Jaeger is typically doing. You could customize it a bit by saying, well, if it's this endpoint, then maybe sample 50%, or if it's a health endpoint, don't sample at all, things like that. So Jaeger does support this kind of a slightly more granular sampling policies, but they still upfront and they still like at best they're probabilistic or rate limiting type of decisions. As a result, if your 99% of your requests are successful with no latency issues, hopefully, then you would still get like 99% of sample traces being of that kind. And so you might miss anomalies, you might miss things with the error codes and things like that. And the really, in order to support sampling based on unusual observed latency or error codes occurring in a trace, you need what is known as tail-based sampling or post-trace sampling, where you first collect a trace from all the components in the architecture, and once you have it all, then you can look at it and say, okay, well, something unusual happened, then you may want to make a sampling decision on that, right? And so, but for that, you need to collect all the data, you need to buffer it probably in memory, because you don't want to pay the cost of writing it to disk yet, because that's going to be much more expensive. And so a few systems on the market today do the tail-based sampling, specifically Lightstep. I think Splunk is doing that now, and potentially a couple more that I don't know about. So Jaeger is moving in that direction. We are at Uber. We are working on this same exact functionality so that we can collect a bunch of traces in memory first, keep them for a very short time, and then decide whether we want to keep them in the persistent storage or not. So it's a tail-based sampling solution. It's probably going to be available in open source by end of year.
Oh, very cool. That's good news. Um, So I read that you're working on a trace DSL. Do you have any example query, and will it be Java only at first? And did you get some inspiration from the DSL in Canopy?
We did get some inspiration, but unfortunately, the Canopy DSL was never really published. There's like a small snippet in the paper, so that's the only thing that we know about it at this point. And so when you look at it, what it says is that, well, you can iterate through spans of a trace, you can compare like conditions. So it's some sort of a Python API, somewhat similar to Pandas, where you can generically express conditions on the elements um, of the span details, right? And so we did have plans. We haven't like moved on them yet to do the Python based API for traces. I think it was easier to start for Pavel, who was working on that part from Red Hat. It was easier for him to start in Java, and so that's what we currently have. So right now, and he published 2 blog posts which you can find from Jaeger website about the DSL itself, which is based on like it's a graph traversal DSL, but you don't really need to use necessarily graph traversal. It depends on what kind of expressions you want, right? In
Mhm.
many cases, when you analyze traces, you actually want information from individual spans, which is you can even do that in a relational type of storage. For example, at Uber, the tracing data that we collect in Jaeger is also shipped to Hive, to HDFS clusters, and we have an SQL based solution that you can query Hive, and so a lot of data we can just crunch from the like historical traces based on a relational model where a span is a single row. But if you want something that is more uh, sensitive to the path within the call graph, let's say I want to see like parent A, child B, and grandchild C, and you want to derive some sort of relationship from that kind of information, then you do need a graph representation of the span, which is very hard to do in a relational query language. And so for that purpose, the graph-based DSL is more suitable because then you can express those traversal decisions and then add the extra filters at every step, and then express some whatever signal you want to extract from a trace in that form. And so right now I think that DSL is kind of in an alpha form, is available. It could be used from Jupyter notebooks. Um, I think it also can be used with the just either Spark or Flink. I don't remember details there.
Mhm. Could it be integrated in the UI directly in in a simple form where people could enter their query also?
Unlikely, because the intention of this API is really to give programmatic access to things that you cannot necessarily express in the UI. But more importantly, we just don't know. The tracing um, world is fairly new area
Hmm.
of observability. And so there's a lot of experiments people and a lot of features people may want to extract from traces. We just don't have resources to maintain UI for every single feature that people want to extract. And so that's why programmatic access gives people a lot more flexibility with experimenting, saying like, oh, well, if we build this kind of features then and we find them useful, then we can decide, do we want some form of UI, maybe some form of persistent aggregation running in production at real time and collecting those features from the traces. But yeah, it kind of depends on what whether the information you're extracting is useful for you or not. So no plans for UI for that part.
Okay. How many people are working on Jaeger at Uber? If this is something you can tell us.
Um, well, I think on average 5 to 6 people over the
Okay.
years.
Um, Another question. Well, I guess you already answered this one, but someone asked for microservices, why would I need tracing overall?
Uh, well, it's a fair question. The It's kind of ironic that one of the biggest questions that people don't ask when they develop software is, how do you know that your software is actually doing the right thing when you deploy it in production, right? So sure, you tested it locally, but once it's deployed, and especially if it's a microservices architecture. We are talking about very complex distributed systems, which can have all kinds of unexpected behaviors that you would never reproduce necessarily in testing or even think of, right? And so you do need robust monitoring to know that your software is working correctly. And when it's not working, robust observability within that software to drill down and find out why it's not working. And the uh, the monitoring part of that question is usually answered with the metrics telemetry, where you just emit counters on how many errors you're observing in your application, and that way you can define sort of service level agreements for your software and say yes, it's operating to like how my customers want it to operate. But as soon as something is broken, and let's say your SLA is broken or your metrics go wild for like the error rate spike, um, the metrics as a observability tool doesn't give you the ability to investigate that, because metrics are by their nature focused on individual node or individual instance of a service, or maybe like a group of service instances but for the same service. And in microservices you definitely have a lot of different services participating in the requests, and traditional monitoring tools just don't give you that visibility end to end. And that's why distributed tracing complements the metrics and logging telemetry by giving you visibility not just for this single instance of whatever of the component of the architecture, but saying, well, I can not only look at this micro view of the thing, but I also take a global view of saying how the whole request looked like, right? And essentially it's also I actually think that when we develop software, our mental model is thinking in terms of workflow. So if you're writing even one service, you're saying, okay, I got this request, I'm going to make a call to this downstream service to do authentication, I'm going to make another call to the other service to get like user profile. So you're thinking in terms of a flow of a single request. You're not developing saying, oh, I'm going to have a thousand requests simultaneously and they're all going to do something smart, right? No, you're thinking about what one request is going to do. But traditional telemetry don't give you that picture. They tell you, oh, you did get 100 requests per second or like 200, and so that's completely different, like a perspective of how the software is operating versus how we develop. Whereas distributed tracing actually allows you to look at your behavior of the performance of the application from the same perspective as you develop and saying, this one request, let's see what happened front to end to that single request. And that's why distributed tracing is so popular, especially in microservices architecture, because no other tools really give you that visibility.
Okay. Um, Someone is asking what's the difference between tags and baggages.
Oh, it's a good question. So tags are annotations you add to the spans which are reported asynchronously from the process, right? So as I mentioned, there are two data streams happening as far as the tracing data. One is as part of your business request, where some information is propagated through the call chain. And another is the actual performance data collected asynchronously. So tags are part of that performance data collected asynchronously. So let's say you're making a database call. So you can create a tracing span around that call. You can set tag to contain an SQL query. You can set another tag to contain, I don't know, some parameters, some user ID, maybe database name, table name, things like that. These are things that they only belong to that single span. And if the whole trace is not sampled, then nothing is going to get collected at all, right? So setting a tag on an unsampled trace is a no-op. Whereas if the baggage is different, baggage goes to the first data stream. It's actually the thing that gets propagated through the call graph between services. So you can think of trace ID itself as a baggage in a way, because we're saying in order to reconstruct the whole trace from multiple services, we need to tag all the executions with this one single unique ID of the request, right? So that's what trace ID is. And baggage is the mechanism really of propagating that trace ID. It's something that is also called distributed context propagation as an alternative name. It's a general purpose mechanism that you're saying every request has a metadata section within which contains some payload, completely arbitrary. Any individual service doesn't even need to know what's in that metadata. The only thing they must do is pass it on to the next hop in the call graph, right? And that's what baggage is. And so like one of those attributes of the baggage could be a trace ID. You can logically think of it that way, but you can also put any custom metadata. Let's say it was like a good example is, let's say you have some e-commerce site, and you have a lot of requests coming to the database, right? um, well, maybe yes, okay, and e-commerce may not be good. Think of like Google. So you have Gmail and you have Google Docs, right? Two top
Mhm.
level large applications. They probably all hit some kind of database at the bottom. It could be Bigtable, it could be Spanner. I don't know what they use these days, but it's some shared platform that is available. And at that platform, it's actually, from the business point of view, it's useful for you to know, well, did this request actually came from Google Docs or from Gmail, right? Because if you know that, you can do all kinds of smart decisions about capacity planning, how you allocate resources. If you know that your Gmail is going to grow like this much percentage in this year versus Google Docs is fewer, then you can again project how you want to essentially attribute the cost of running this shared platform to your lines of business, right? And but the problem is that in the microservices architecture, the Google Docs, the only place that knows it's a Google Docs is somewhere way up at this call stack. It's like you have some gateway, you have some microservices which actually specific to Google Docs. But by the time you reach all your like generic storage layer, that information is typically lost. All you know is just, well, I'm just, I don't know, hitting database with some tables, right? And baggage allows you to bridge that gap because it's the context that you can propagate with the request. So you can at the very top say in the baggage, say my business line is Google Docs for this request. And then every single service that participates in that request will see that attribute, and they can do something. They can emit additional metrics. They can tag the metrics with that information, for example, or they can record any other performance and capacity data that you want. So that's what baggage is. It's very different from tags. Tags is like a performance data.
Okay. Um, so batch gives great context in comparison to tags. Um, uh, well, I already know the answer to this one, but someone is asking, is there any Apache Flink integration? So the answer is yes. And is it mature? Um,
Um, Apache Flink. Well, there's. It depends on what they mean. So there is a question of, can you trace these big data pipelines themselves, right? So when we're talking about big data, it's not the microservices world anymore. It's really the pipelines, like Kafka in the middle, maybe. And so it's actually sometimes very useful to be able to trace those things as well. I don't know if there is actually out of the box instrumentation for Apache Flink. I don't recall seeing that. We at Uber, we do trace messages passing through Kafka.
mhm.
So there is a definitely instrumentation for Kafka specifically as a messaging platform. So you can carry over this distributed context as part of the message written to Kafka. And so that way you can collect traces and observe like who produces messages, who consumes them, like what's the latency. So the typical things that you use distributed tracing for, but on the streaming platforms, right? But with Flink, it's slightly different because Flink itself is so it's actually it's even probably more aspects to that question. Like you can say, well, Flink itself is a distributed system because it has master and workers and they communicate in some way. So technically you could trace that activity as well. I don't think that tracing is implemented there, but because they're Java services, it's actually not hard to just auto instrument them using like Java Special Agent, for example. Uh, and so yeah, and the integration that exists with Apache Flink is what Jaeger has in terms of processing tracing data using Flink jobs and extracting aggregate information, which is probably what this question was about, really, rather than instrumentation.
Okay. Let me see. So, what is the status of open telemetry now that it is in beta? Can we use it for the collector and everything, or what do you
Yes,
recommend?
as far as I know. So as far as recommendation, it's a bit um, unclear situation right now whether I would recommend this for production because it is not production at production stage. Yes, general availability is planned in a few months, but right now it's a beta. So if you're okay with the beta software running in your code, then yes, you can start using it. It's definitely already compatible with. with the Jaeger backend, you can instrument the code with OpenTelemetry and have all the data sent to Jaeger backend. But as far as whether you want to take that step right now or wait until OpenTelemetry is more production quality, it's up to the organizations to decide. In some cases, like organizations like Uber already has invested heavily into open tracing. So
Mhm.
for us, it's an even shakier proposition of, do we want to spend cycles rewriting or augmenting that instrumentation to switch to OpenTelemetry? Probably not at this stage. Probably not, maybe even in several months. But in a couple years, I expect us to switch to that, because then we don't have to maintain Jaeger clients going forward as part of the Jaeger project. We can just say, just use OpenTelemetry on your applications, and even in the collection pipeline, if you use the OpenTelemetry collector. And then on the backend, you use Jaeger to actually process the data.
Mhm. And Java has something called a special agent that you mentioned to automatically add tracing to your apps. And in OpenTelemetry, they also have something similar. I think it's auto ingest. Is that it?
Yeah, it's auto instrumentation,
Auto instrumentation, yeah.
for
And
lack of better
and
name.
there's also in Python. Do you know if there will be more language added, such as Go, Ruby, whatever?
Yeah, the plan is to add it as in as many languages as possible. I believe there is already some for JavaScript as well. Um, I haven't followed every single language closely. There's like the Open Telemetry quickly grew to be too big of a project for me to follow every single
Yeah,
special group there. But yes, auto instrumentation. I think Go is definitely one language where there is no plans to do auto instrumentation, because it just doesn't, the language itself doesn't lend itself to that. But in languages where you can do some sort of like monkey patching as in Python or JavaScript, or bytecode manipulation as in JVM based languages, then there the plans are to provide auto instrumentation as
and do you recommend using auto instrumentation in general, or do you think it's
well.
must be a combination?
That's an interesting question. I think using auto instrumentation allows you to roll out distributed tracing a lot easier than
Yeah,
by doing it obviously explicitly, right? And uh, commercial vendors have been doing that for many years. Like New Relic, for over 10 years, they've provided this instrumentation. Datadog recently built their own, and that's the foundation of let's say OpenTelemetry auto instrumentation for Java. It's based on Datadog agents, right? So it is fairly high quality instrumentation. Um, and if you're only using it for observability, then I think, yeah, just go with it. There's really no reason why you would want to just go and like start manually instrumenting your frameworks. However, there is another aspect to that is if you go back to context propagation question, right? Um, the the situation I described with Gmail and Google Docs was also more of a observability situation, right? So I said we add a business line as baggage and we propagate it, but then we use it only for observability purposes. However, distributed context can be used for many other purposes. Like you could, for example, record user token or user identity in the baggage and then do some like fine-grained authentication to the storage layer, right? The original identity of the caller, which is really, there's no other technology that can provide that capability aside from just passing and changing every single API to pass that user ID in your whole stack. And for that kind of behavior, we are no longer talking about the observability function of baggage. We're saying, no, this is actually going to affect how my application behaves, right? And that creates a bit of a question. Do you want to depend on bytecode manipulation or monkey patching for that kind of functionality? You of course can. I don't think it will be less reliable. It creates a bit of a friction in the development cycle, because imagine that you're running unit tests in your application, and unit tests are checking this behavior that depends on the context propagation. Then suddenly you need to bytecode instrument your unit test, right? So it's kind of get a bit tricky. But that's probably two obscure reasons for many people to even think about it. So I would definitely say, just like, yeah, try it out, see, because you can get a lot of value just from observability function of auto instrumentation, and then you can figure out what you want to do with like more general context propagation.
Okay, and you mentioned like static language like Go, where it's more difficult to implement because there is no monkey patching. Do you think it makes sense to have like semi-automatic integration in libraries, for example, in routers and ORMs? Do you think it makes sense for a library author to integrate with OpenTelemetry and Jaeger?
Sure. Not with Jaeger, with
With
OpenTelemetry. Yeah,
OpenTelemetry, yeah.
yeah. Um, Definitely. I mean, this was sort of the hope, the original hope of the open tracing project was that if we can come up with this vendor agnostic general purpose API for describing distributed transactions, then all kinds of software can just start instrumenting themselves. And if you don't have a tracer plugged in, then it's a no op. But if you have a tracer, you suddenly get rich information about your all kinds of frameworks that you're using in your software, right? And that's the same hope that kind of transitioned into open telemetry now. Um, History has shown with open tracing that people were reluctant to put open tracing directly into their projects, although there are some projects that did that. Uh, uh, but if we're talking about more general purpose reusable frameworks, let's say an RPC or database driver, then a good design of those libraries is to support some form of middleware where
Hmm.
you can attach decorators or something interceptors that allow you to slightly alter the behavior of it or at least observe it, right? And so that if the libraries are designed in this way, then it's actually very easy to add OpenTelemetry instrumentation as a third package. You don't need to build it directly into the actual library uh, natively, but you can always just provide an extra package saying if you enable it, it will install an interceptor, and then you'll get OpenTelemetry based tracing in your framework, right?
Yeah,
So
that'd be
that
nice.
that's how it's been usually. Because like in open tracing registry, if you go there, there's over 100 different packages, and most of them are of that kind. It's not like something that's natively instrumented in software. But there have been software like I think Couchbase or
Yeah, I think so.
one of those databases. They kind of built tracing natively using open tracing, so that's another alternative.
And is there a lot of code rewrite from open tracing to open telemetry, or is it mostly
No,
mm,
there is not a lot of code rewrite. I mean, the API is different in the naming, but not conceptually. Like you're still doing the exact same operations, capture and similar tags. You're just using like different constant names and method names. The rest is similar. So I think it's possible to even write some linters or automatic rewriting rules that you
okay?
can just run on a code base, depending on the language. If people want to invest in that. Like you mentioned Go, which is a like a static language. So in Go, one interesting thing is that the context, the notion of a context, is built into the standard library and highly
Yeah.
recommended to use,
Hmm.
which actually solves one of the most difficult problems in the applications of the context propagation. Because with the distributed tracing, adding middleware to your RPC frameworks is fairly straightforward, especially because there is already everything is written in most frameworks. So you just like attach an extra interceptor, and suddenly you get tracing on inbound and outbound uh, calls. But like in process context propagation is often more difficult, especially like if you in Java and you're using multiple threads and executor pools, then uh, like keeping the context within the threads, it may become challenging, right? In Go, that's actually much simpler because Go said, well, no, just pass the context and that's it. So you make it the responsibility of the developer, and it's a culture in the Go ecosystem to do that these days. So that solves that problem. But as far as like middleware, yeah, just develop frameworks as with support for middleware, pluggable middleware, and then that solves the problem.
Okay. Um, do you have plan to improve comparing trace structures, like some kind of diffing?
Oh, we already have that in Jaeger.
Okay.
We released it over a year ago, so you can compare two traces. And we support currently two different modes. One is structural comparison, which uses like a code diff style with red and green color for stuff missing and added. So you can easily see, like, if something is huge chunk of nodes is in red, you know that like the second trace didn't execute this whole chunk of the flow, right? And so that's actually very helpful sometimes in analyzing the large traces that we get at Uber, which may contain like several thousand spans, and so just using the regular Gantt chart view is kind of difficult. You can also diff them based on latency of the spans, which also kind of uses color coding, or more of a heat map color coding, and you can easily see where the requests are going, or like where the latency is spent within the trace. Um, I gave a talk at KubeCon Observability Summit last November, December, where we also presented a tool that we built internally at Uber, where it extends this notion of diffing to diffing not just two traces, but one trace with uh, a statistical model of combined from multiple traces, which represents your typical behavior of the system. So that is also a very useful technique for analyzing if you have an outage or some sort of anomalous behavior that you're observing in your production system, and you want to find out like what's actually broken in this thing. And so you can look at the diff and saying, oh yeah, I see this whole section being red, and it allows to kind of, if not root cause completely the outages, but at least pinpoint what problems within which services exhibit some behavior that's breaking overall execution of the flows.
Um, when it comes to storage, someone is asking, do you what would you recommend Elasticsearch or Cassandra, or is it whatever?
Um, well, it's not whatever because Jaeger doesn't support anything else really for distributed storage. Although Jaeger does have a notion of database plugins where you can implement a plugin for any other type of storage, and it just communicates over gRPC. But yeah, out of the box, Jaeger comes with Cassandra and Elastic. If you were just starting out in relatively small organization, I would recommend starting with Elasticsearch because it provides you better search capabilities than what we have with Cassandra today.
Do you use Elasticsearch at Uber or?
No, we started with Cassandra because that's how we had already operational expertise in the team with it, and also because Zipkin I think was only supporting Cassandra at the time, so we kind of were there wasn't that much choice at the time, and we continued running on Cassandra. But we are moving away from Cassandra into completely different types of storage that um, at the moment we don't plan to do like much open source work on it because it's really tied to internal offerings at Uber. But specifically, we want to um, separate a single storage into two parts. One is just a storage for traces, and we plan to use a blob store for that, similar to S3 but internal to Uber. And for indexing spans, so that you can search or even get some analytics from them, we're planning to use a columnar store, which is again it's internal to Uber, but it's based on ClickHouse. So this kind of work is going to happen probably in the next few months,
Mhm.
and we hope to achieve two things. One is the blob store gives us a lot better resource utilization than Cassandra for span storage, and columnar store just beats everything in terms of its ability to search and provide analytics on top of like aggregates on top of traces. I think it will be much more efficient than Elasticsearch in that regard.
Okay. And someone is asking, what are the cons of sending spans straight to the collector and bypassing the agent? Is it?
Um, so it really depends on how you deploy Jaeger. The reason that we originally developed an agent at Uber was because we did not want to introduce dependencies into the applications on the service discovery or anything that needs to know where the collector is, right? So when you have, I don't know, 3,000 microservices in several languages and different frameworks, so you bringing your Jaeger library into that application, and you want to make as minimal impact as possible on the application, both in terms of performance and also in terms of the dependencies that you pull in. Because if you pull a lot of dependencies, then you have lots of conflicts, and things like bad things happen. And so for us, the easiest way was to just say, you know what, I don't care where my collectors are. I'm just going to emit data to a local port on UDP. Uh, Almost every language has that kind of support natively in their standard libraries, so you don't need any third-party libraries to even pull for that. And so that kind of minimizes the impact of Jaeger clients on the application. And that's why we run an agent on the host, because, well, all the applications just send data locally to the host, and then the agent picks it up and sends it to collector. And in the agent, we can implement any sort of discovery or routing policies that we want. Um, and so that was the main reason why agent exists. You don't have to use it. You can always configure Jaeger clients to talk directly to collectors. I think HTTP is probably the only support that we have currently. C# recently added gRPC for that, but I don't think any other clients do gRPC yet. And so that's another alternative. It's just the kind of the drawback is that you need some sort of stable collector name, which means probably some DNS name what you can route. So in Kubernetes, that's usually not a problem, because that's how Kubernetes is actually implementing service discovery through DNS names. But if you're on some kind of other architecture, then it may be more challenging. Like at Uber, for example, there is no such thing. If you want to reach a particular collector, you do need to talk to service discovery and find what the addresses are, and then decide which one you want to talk to. And it just like that's extra logic that we didn't want to support in multiple languages.
Okay, thank you so much, Yuri. So you released a book on um, mastering distributed tracing.
Mhm.
We'll send the link to everyone so that they can have a look in the comments. Do you recommend the book for anyone interested in Jaeger, I guess?
I would say this book is more about distributed tracing in general. It kind of came out in slightly inopportune time because of this conversion from open tracing to open telemetry. So I have two large chapters which actually walk you through in a lot of details about how you instrument services, including both RPC and streaming based, like Kafka based services, right? Uh, and those all those examples in open tracing. So they're kind of at this point a bit stale because, well, the world moved to open telemetry overall. But as I mentioned, the APIs for tracing in both of those projects are very similar conceptually. So yeah, the names might be different, but the actual meaning of the method calls are identical. And so if you want to understand how to do instrumentation, it's still very valuable chapters that you can go through and understand if you need to instrument your software. But besides that, I think the other large chunk of this book is about history of tracing, how you like what other methodologies people use for tracing, and also how you deploy tracing in a large organization, because that has been and still is a challenge at Uber, given our history of like builders, let's builders build, where we have so many languages and frameworks. Um, yeah, there's actually very little about Jaeger specifically in that book. There's one
Okay.
chapter about like even that chapter is focused more about how you operate tracing infrastructure in general, but specific examples are for Jaeger.
Okay. Oh, one last question I forgot. Someone was asking about Jaeger API to pull data out of it. Like if someone is writing a dashboard and want to extract data about traces from Jaeger and show them on their dashboard, is this possible? That's the question.
So there is a gRPC API in the Jaeger query service, which allows it essentially expresses the same functionality as what Jaeger UI has. So you can search for traces by various criteria, and you can just pull traces directly from the storage using that API in the protobuf format. And the same API is technically available in a JSON kind of REST style. That's what Jaeger UI uses, but we don't declare it as officially supported because like gRPC is very well documented. You have a proto file and it's very clear what's going on there. Whereas the interface between Jaeger backend and Jaeger UI is more of a kind of proprietary thing. We didn't really want to say, oh, just go and use it. And
Yeah.
so it's technically subject to change, whereas protobuf, if it changes, it will be backward compatible for sure.
Okay. Well, thanks. I won't take any more of your time. It was super interesting.
Problem.
Is there anything else you'd like to tell us before leaving?
Oh no, I mean, I'm happy to participate in that. I think yeah, Q&A is kind of the most fun form of of meetups for me than just a presentation. People get bored at presentation, I feel like.
Okay. Well, thanks, Yuri, and thanks everyone for tuning in, and see you next time.
Okay, thank you, Raj.
Thanks.
Have fun.